Welcome. Thank you all for joining us today as we kick off our monthly virtual workshop series for the spring with our first virtual workshop of 2025. My name is Drew Scammell, he, they pronouns, and I'm a program associate at the Center for STEM Education and Workforce, or CSU, at the American Association for the Advancement of Science. On behalf of our AAAS IUS initiative, I'd like to welcome you to today's workshop, incorporating interdisciplinary teaching approaches into STEM curriculum. Today's workshop will feature presentations from Dr. Li-Qiong Wang and Dr. Kumar Pial. Before we jump into the workshop, I have a few housekeeping notes I'd like to go over. This presentation is being recorded, and the recording and the speaker slides will be made available in the coming weeks on our website at AAAS-IUS.org. You'll also receive an email with a link to the archive when it's available. And please note, we will transition to Q&A discussion breakouts following the presentations, and those breakout rooms will allow for deeper engagement and will not be recorded. Additionally, we have closed captioning for this workshop. You can download and view the full transcript by clicking the CC button at the bottom of your screen. And for those of you who are new to AAAS IUS, this initiative seeks to support faculty and students in the greater undergraduate STEM education community by disseminating research and knowledge about STEM teaching, learning, equity, and institutional transformation. We invite you to learn more about the AAAS IUS initiative on our website and hope you'll join our community as featured contributors. You can also follow us on X, or formerly Twitter, at IU's program, and LinkedIn to stay up to date on our latest events, blogs, or to share what you've learned at today's workshop. And now we'll shift over to the first presentation of the day. Without further ado, I'd like to welcome Dr. Li-Qiong Wang, Distinguished Senior Lecturer at Brown University. So Dr. Wang, I will pull down my slides and hand it over to you.
Thank you. Let me share my screen. Can you see my screen right now, everyone?
Seeing the screen? Yep. Perfect.
Oh, good. Okay. Good afternoon, everyone. Welcome. Today, I'm going to talk about collaborative, interdisciplinary, and student-led approaches in undergraduate STEM research, teaching, and learning. First of all, I'd like to give you a brief introduction about why we're doing this kind of work, motivation, and methodologies, and also introduce you unique undergraduate teaching research award facilitated by Brown University. And then I want to just focus on the new, relatively new chemistry and art course we created recently by using new methodology in practice. Then I also going to talk about challenges and outlooks, how you can adopt our approaches and scale up to fit your institution or your environment. Finally, I'll give a brief conclusion. Okay, why we're doing this kind of work, what kind of approaches we're using? There's so much interest in using collaborative, student-led, and the interdisciplinary learning approaches in current education. It's being proven to be very effective, also based on also by constructive theory. And however, few existing models integrate all the three approaches in one curriculum or in one setting. So our approach is to demonstrate here, we can create two interdisciplinary courses called chemistry and art, and that will bridge this gap with a hands-on student-led or driven curriculum. We like to connect theory to practice through this real-world applications. Our goal is to develop critical thinking, creativity, and the problem-solving skills for students and prepare students for interdisciplinary challenges beyond the classroom. And also, of course, inspire students interested in STEM education through innovative applied learning. So our approach is this, I can describe as the three big areas. One is collaborative approach, student-led approaches, and interdisciplinary approaches. We are looking at intersections, three of them together will have a synergy effect. So which means we can create some very unique interdisciplinary courses that be proven to be very effective. which I will show you later in the following slides. So before I talk about together those approaches, so let's talk about what is collaborative approach in our sense. So collaboration means many, many different collaborative. So we can collaborate between student and the faculty in research and learning, collaboration among students in peer learning, and also collaboration among the faculties in the disciplinary teaching. So those are the collaborative approach we're going to use, we have been using. Now, this is really unique program offered by Brown University called Undergrad Teaching and Research Award. So this award allow students, really outstanding students, to collaborate with faculty in terms of research or curriculum development. So what are the benefits? This benefit fits our approaches. Collaborative teaching enhances learning and integrate real-world applications, critical thinking, creativity into the curriculum. A distinct student voice and a unique perspective have significant enriched courses has been proven based on our experience with ultra-driven changes boosting student engagement. I will also show you some examples in the following talk. Also, Ultra allowed student-led research experience, not only just develop curriculum. During the develop curriculum, in our methodology, we let the student drive research experience and convert research result into the teaching, which make that teaching material more learning effective and more engagement. So this is one of the example we used the Ultra to develop this innovative interactive animated lab videos during COVID with this diverse students working together to make a beautiful, like at least 4 or 5 interactive animated videos that were so helpful for the online learning. So this video guides student, very short, guides student to do the experiment with interactive component to tell them if this steps right or wrong, and also with animation in the beginning to engage in their interests. And also, this is also the result of Ultra. I just show you a couple of quickly result. Those are engaging experiment as the collaborative effort and student-led Ultra program. So this is, first of all, is the introductory laboratory using different colors to look at equilibrium. And also another one is acid rain experiment to correlate environment and simple titration acid-base reaction and with the environment, so acid rain. The other one is we also, for the upper level class, we make the student make a quantum dot. So really all this fun, interesting color, make them really get excited to new knowledge and new technology. This one, introductory quantum mechanics and origin of color. This is introduced like a few years ago to our general chemistry laboratory. This one actually really stimulated me to think about what other laboratory experiment or another new course we can actually combine chemistry and the color, because based on this introductory laboratory, students really overwhelmed approve this lab, say they are so interesting, they want more of that. So this is how I start to think about how I can create a new laboratory using all 3 different approaches to see how those can help us students to learn to be very effective and to stimulate student interest in STEM. So this course is an interdisciplinary course exploring chemistry behind art and art objects. We do 4 different chapters, do color and its origin, chemical origin, physical origin, how you look at the painting, the color, and the textiles color, and the ceramic color. So guide student to look at the color and its mechanism. And then student will do synthesize paint, then look at the painting after synthesize, looking at color change, chemical change, and to form the whole semester-long research project. Then they also do pottery ceramics. They use the color, the synthesized pigment to make a glaze, and then looking at the function of the temperature, the color changes function of temperature. Finally, we go to the museum, museum class to curator to actually teach them the art conservation. And then we also have lecturing. So we have all kinds of content in this one class period, 2.5 hours each week. We combine the hands-on activity unique and the lecturing and the case study and 2 final group essays, case study essays, and the museum visit and a facility visit, and the hands-on measurement of infrared spectroscopy all together in one class period. So what made this class so to me is very unique. It's because we do actually create 2 bottom-up novel hands-on activity, make this very special rather than there are few other classes called chemistry and art. They're looking at art object, just looking at the old painting, then they do some XRF analysis. We're actually making our own pigment to see the color change, then relate chemistry and art and the history together. Okay, so this one is the bottom up. So they synthesize their pigment, they paint, then they see the color change, then relate to historic event or art object. And they also, because the hands-on activity, we see color change, we can use that as a whole semester long research project, which actually makes students really inquiring the knowledge, critical thinking, creativity to find out why the color change, what's going on. And then we also adopt business school, medical school case study into our class. We let students write case study papers. And from that paper, students actually really growing into critical thinker, independent thinking for how to analyze data, how to looking at historic event in the new angles. Then we're all integrating all the components together. So those are the students in the classroom they discuss. So as I said, case study actually really came from the business school, medical school. Many universities adopt that approach right now for teaching STEM. So this shows, our class shows is really, really powerful in terms of writing a case study paper, looking at art, case study art, articles, and the events to analyze them. It's really increasing student engagement and the critical thinking skills. Now the next one is, I want to show you how we really come up some really interesting research ideas and turn that research into teaching. As you know, research and teaching is interchangeable. So research can stimulate teaching, teaching can stimulate interest. So the teaching by teaching Gen Chem lab I just developed some origin of color lab. Stimulated my interest to do some research. Okay, maybe color itself, pigment has a lot of interesting stuff there. So that's how we do both. So in this way here, we focus on how how research in this class, research for this 2 hands-on activity to help our teaching for chemistry art. This is my focus. So, so the research starts on the help of Wutra, as we talked about before. And I have just 2 undergrad students working with me in the summer 2018. They spent the summer there. And I just basically, for me, this is a basic student-led research project. I let them think about really broadly. Anyway, I encourage them thinking creatively, independently. So then we can eventually we can come up very interesting research result. So that's what happened. So this is start from very simple, surprising color changes. Then we dig into what is the chemistry there. Then how we are going to find out why the color change happened. So simple thing, I know we have a wide audience. Some of them are not chemists. I just explained to you just very simple way, not into too detail. So we basically use the simplest salt, copper sulfate plus sodium carbonate, like soda, put together in the liquid solution, boom, boom, just in the 20 minutes, 30 minutes, you just form a beautiful blue precipitate. Then you just filter out of those precipitates, like making coffee. You got this beautiful synthesized called malachite. Everybody, if you know rocks, malachite is a rock. Chemically, it's the same as malachite, but the color is not as the malachite. So it's a blue. So what do? We put the two different binders. One binder is acrylic, water-based. The other one is oil binder, linseed oil. Like after hour or 4 days, they change colors. One is still keep the same blue color, the other is the green. Just the simplest observation led us to really, really long research route, so research journey with these two students. Then later it's helped by one of the graduate students who advisor has accessibility to some of the advanced techniques. So that's how we start. So in order to find out the reason, I don't want to talk about too much detail. Basically, we do a variety of interesting chemical analysis. We found out the simple way we find out the pigment blue is not the malachite. If you want to synthesize malachite is a green color. If you go to the rock, looking at the rock, the malachite people make a jewelry. It's beautiful green color. So if you look at that, so you can see we can actually make a malachite if we put that same precipitate for another week into the same beaker. Do not just filter out of the precipitate. We got this green color we call the green base. But from the analysis, so basically the bottom line is the blue pigment is amorphous material of malachite. It's not true malachite. It's called the different name Georgite. They have very different characteristic of XRD, characteristic of color. And then the key techniques to find out why is very straightforward. Fourier transform FTIR spectroscopy. People who do not know this, but basically you're really looking at the chemical change. It's the pigment, why they become green, must be interaction with linseed oil. It does not interact with acrylic. Why? Then we figure out linseed oil have auto-oxidation, all this interesting chemistry. And then we found the key evidences. We found the linseed oils, the function who bind to the metal copper 2+. That is the key part to solve the mystery. As the result, we publish a journal article in coloring, in the coloring journal, and with the undergraduate. If anything highlight on the score, are the all undergraduate. They are primary authors. So now let's talk about how we make this research into the teaching. So we just let student paint. So the left is the painting. You want the student paint two different blues, do not mix with any commercial, then to see what's changing. Ask the student write essay before and after changing, and ask them to assume or propose what is the reason. That's the first essay. So this is how students do the activity. They do need a hood, so they do the synthesize in the workstation, and then very simple, straightforward, then they do paint, and they will finish in 2 hours. And the most important thing, they write essay. They have very interesting, encourage their creativity. Why we're saying case study essay, the final 2 essays to ask the student to write essay in a way like a general audience to understand. Avoid jargon and avoid other things, but scientifically has to be sound. Use all the data we provide. Some of them, FTIR, they make their own measurement, but other things like some other like XRD, we provide the TA's data for them to analysis. Again, the unique semester-long research project make this course very unique is because they actually really dug into the data, talk with the group member, make sure they understand how to explain all this chemical change. The most important thing is they have to relate it to the art history or art object in history. And they have to write interdisciplinary essays rather than just report a summary of the research data. So the essay needs to be engaging, storytelling, scientific sound. They don't need to detailed explaining which peak, which spectrum is talking what. They talk about the spectrum, what spectrum to tell us about the conclusion or some kind of findings. So I don't think I would skip the second hands-on activity, which also produce a really interesting scientific data. We really actually first time doing this interesting thing is nobody has done. This is the glaze that make the student, the research-wise, we make our own glaze, then have very different colors to starting material. Then we look at the color change. So you will see color change from different temperature and correlate with color change, then correlate what's happening in chemical composition. So basically tell student when the color change is the copper actually from glassy materials with the glaze to form new complexation at the end of the product. So I will skip this part. So the student not only learning science, they make their own object and then they can take home as the art, look at the likeness. So they really also write essays about this activity, explain, how to relate it to the ceramic art, okay, in history. So everything they have to relate to science and art, they have using two different angles, from art looking at the science, science looking into the art. So they also have a good facility visit. So some of them, students only perform their own FTIR, which is the key evidence. XRD, SEM, Raman, and EPR. We have the sample TA, UTA, undergrad TA to send to the facility manager. Sometimes our graduate TA helped us to do some measurement. And the in-class demonstration, we have XRF, in-class demonstration, UV reflective measurement to let the student know the color green, its form is now mixing yellow and blue. So that's very key evidence for them. Okay, anyway, also, we have the class in the museum. Conservator Ingrid Newman, we're very lucky. RISD Museum is one of the top museums. So students learning the real conservation art. Oh, in addition, because we talk about color, origin of color, the neuroscience is very important. So we have also invite speaker to give Leslie, give the eye, how the eye perceive color, all this stuff. And the ceramics, we invited East Asia study, who is expert, Professor Chen, to talk about ceramic art in China, Qing Dynasty, how's their kiln, how they work in the empirical kiln. So now we do the feedback. I would not focus on all the detail. I think the important feedback, students really, really enjoy this class, and they think they learned a lot of different critical thinking and engagement. And we want to see the challenges, because this feedback is not perfect, because we have a small class size. Look at the 9 + 3 + 1 is 13 students. So what is the challenge? This is the important part. Before I finish, I want to talk about challenging. and adaptability and scalability to all the community who really, even you're a physicist, you want to adopt this kind of interdisciplinary thinking to how to adopt this really research type chemistry and art course with kind of more like a towards upper level understanding of all this art object with a variety of techniques, variety of resources. How do we adopt this? So, so what is the key part is class size right now is 13, funding constraint. What about student you don't have ultra? How do we get to do the research to teaching? With limited enrollment, we need a workstation. Some university have no workstation. What do we do about that? Assessment, this assessment, what is the better assessment? So I show you a little bit what I'm trying to do right now, just give you a little bit thinking so we can have a little more discussion in my breakout room. So let's talk about enhance. I wish the future we do enhanced assessment, like interviews, focus group surveys, scaling to a large classroom. I already tell you what I can scale up for this semester. I double the size, and also expanding interdisciplinary community engagement. So we have to think about that part. And we also want to do continuous feedback. So the assessment, I think we should assessment by 2 final case study essays. We have a rubrics. We can use the essay to do assessment, which is student actually did a really, really good job using new angle to study and do really good writing to combine art and science. So this is one of the evidence. 3 students who just took my class 423 were invited to write journal articles, review article in coloring, which is very interdisciplinary journal research article, has highly cited because we write in a very interesting way to be able, the artists can actually understand. So this is the today's, took a picture, the white, the bottom right, it's the color for 22 students instead of 12, 13. They see color changes today. We did last week's, and we did, if you don't have workstation, we can do the lunchroom. We can synthesize, pre-synthesize the pigment. Student can still do, they can still do research. Okay, conclusion. The chemistry and the art class course serves as proof of concept for integrating this methodology, highlight the potential for broad application cross discipline, aims to guide educators in implementing similar strategies to enhance undergraduate education. Thank you all for listening. I can discuss with you. I come up a lot of questions we can discuss and the Q&A in the breakout room. Thanks.
Awesome. Thank you so much, Dr. Wang. Now I will hand it over to our next presenter. Next up, we have Dr. Kumar Das, Associate VP for Research and Innovation at the University of Louisiana at Lafayette. So Dr. Das, over to you.
Thank you so much, Bruce. It is an honor to be here this afternoon, Drew. I appreciate it. And Dr. Wang, thank you so much for a wonderful presentation. Can you see my slide?
Yep, we can see that.
Wonderful, wonderful. Thank you again. So as Drew said, I'm Kumar from the University of Louisiana at Lafayette, and today I'm going to talk about an innovative approach, a multidisciplinary approach, multi-institutional approach that we have taken to address the biotechnology workforce challenge that we're having today in the country and worldwide. So to start this afternoon, think about just for a moment, imagine a world for a moment that where the groundbreaking biotech work, biotech innovations are delayed due to not the lack of ideas, but the lack of the qualified workforce. Think about it for a moment. And if you think, you will see that we're right there today. And if you think about the biotech workforce, that shortage that we're having, that picture is agonizing, that picture is frustrating. And if you can go even a few years back in the middle of a pandemic, that agonizing wait to get a vaccine for a COVID-19 type of pandemic can lead us to a disastrous moment, a catastrophic situation for mankind. And for being the home of one of the largest non-human primate research center in the country, we saw that agonizing wait, and we have seen how frustrating it could be. We waited months to get a vaccine, but we overcome that. We overcame that situation, and here today. But where we are standing today, and by the way, I'm proud to say that University of Louisiana at Lafayette, my home institution, is the home of, as I said, one of the largest non-human primate research centers in the country, was the place where the first COVID-19 vaccine by Pfizer-BioNTech was tested. So we are so proud of that. But what we can see on the other side of the tunnel is the lack of qualified, skilled workforce in biotech. So we brought this idea and how we can move from there. But before I go to that particular project, I must acknowledge that this is not just University of Louisiana project, rather it is a joint project with many institutions involved. A few I wanted to start with, and that is University of Louisiana system. That is a system of 9 institutions in the state, the largest in the state. We have about 90,000 students. And my colleague, Dr. Claire Norris, is the Vice President of Advancement, and she is the co-PI of a program that I'm going to talk today. I want to talk with also about a company, our industry partner, CGI, and my colleague there, Ms. Jacqueline Craddock. I believe she's in the audience this afternoon. She is the person from CGI, and she handles the workforce initiatives at CGI. And you may know that, founded in 1976, CGI is one of the largest IT company in the world. It has 400 locations worldwide. And in this small city in Lafayette, south part of Louisiana, Cajun country, that's what we call, it has brought about 800 jobs in the IT sector. So we work with CGI, which I will explain in a minute.
Dr. Das, can you put your presentation into presentation mode so we can get a little bit of a bigger picture of the slides?
Sure, of course. I apologize. So how about now?
That looks better. Thank you.
All right. Sorry about that. So I was talking about the CGI, and then the other important partner in this initiative is our own advanced student research program. And Dr. Sherry Kreisky self, I believe, is also in this audience today, is the core part of this program. She's a co-PI of this NSF-funded program, and she's the director of our Student Center for Research, founding director, I must say. So these components came together to address this biotech workforce issue in the state and in the country. But our focus, when we first thought about that, why so? Why do we need that kind of motivation? So the rationale behind this picture is where we stand today. The shortage I was talking about in my opening remarks. I can show data after data. In 2022, MC Burning Glass study is showing that the manufacturing sector has experienced a 25% growth in the past 5 years, and in the next 5 years, that growth is 13%. If you compare to other professions, the research component in the biotech force is 79% growth compared to 8% in other occupations. So this is a pretty interesting number to look at. So we also studied some of the report. One of them is Accenture report that's showing that 96% of the thought leaders are saying the biopharmaceutical companies believed the ongoing labor shortage would not soon change. And again, a 2019 McKinsey report is showing 9 of the 10 biotech executives and managers say their organization's primary issue is the workforce. So what we have done is we have thought about what we can do, and we looked at the trend first. So the trend is showing that there's a huge growth in the market, and that could be one of the reasons, which is a good problem to have, because our biotech industry has been evolved into a place where we can all proud of. Yes, we know that there are many things to be done, a lot of medicines, a lot of cures has to happen, but there's a huge investment, and that investment is expected to double from 2.12 trillion to 5.7 trillion in the next 10 years. And what we have seen is the RNA-based therapeutics is grown pretty significantly, and our national security is tied with that, as you can understand. So what we have studied, and we found that there are some basic issues with that. There are challenges, and the challenges is there are lack of interdisciplinary skills. When we think about biotech workforce, we imagine a picture of a chemistry lab or a biology lab, but we need even more than that. We have seen that our students are having limited hands-on experience. And as you all know, the STEM workforce is having a shortage in general. So if we cannot move beyond our STEM pipeline, we have to go to the non-STEM point of view. And finally, the diversity part of it, the gender and racial disparities has been significant issue in that sector. So we wanted to address that as well. And if you think about, again, what I was telling you a couple of moments ago, that the biotech workforce is basically a combination of interesting professions. So the UT Austin has provided this very nice graphic. The career in biotech industry is, of course, the research and development R&D part, there's the operations part, there's the commercial operations, there's services. So if you look at, this is a mixture of an interdisciplinary industry. You just do not need specialized skill in disciplines like biology or microbiology or chemistry, but rather you need a combination of many. So what we have done is we proposed to the National Science Foundation that the UL system has a program called RFL Lewis Scholar Program, and that is based on that program we developed this idea of NSF Excellent Project. This is a 3-year project. We have been able to secure the funding of $1 million from the National Science Foundation, and we build a cohort model into that. So if you look at that, we started in the summer of 2023, where we started the recruitment, and in the fall we provided academic support to those students. In the summer of 2024, where officially we started this particular NSF funding, that 18 students. So in the RFL Lewis Scholar Program, they recruit 2 Black male students from the 9 institutions that UL system has. So 18 students, they come to the campus of the University of Louisiana at Lafayette, where I'm at now, which is an R1 institution, and they come here for 8 weeks to do research. This is very similar to an REU program. Those of you are familiar with NSF REU program. So they come here, but again, they're coming from different backgrounds. We have students from civil engineering, mechanical engineering, but we have students from music, we have students from education, we have students from business, accounting, you name it. So in fact, out of those, we recruited 17 students in the first cohort. Only 2 of them came from the STEM. 15 of them are from non-STEM. So in the before I go to the undergraduate research program, let me go through over the program that they do in the summer of 2024. They did the undergraduate research. Then they go back to their home campus in the fall of 2024. Then they receive our academic support in the fall and spring, and then they will come here in the 2025 summer as a CGI intern. Again, CGI, as I said, is an IT company, but it is beyond just the regular IT. They work with all of the largest pharmaceutical company in the world, and they work very closely. So their partners are big name pharmaceuticals. So our students, the interns, will be working in the CGI, and also they will get trained by the biopharmaceutical companies. After the internship, they will receive the professional development during the fall, and in the spring, they will also receive different types of academic support from us. So this is a cycle of one cohort, and then the second cohort and the third cohort is the Nature We Stand. If I can speak a little more about the initiative, as I said, there are 17 students in the summer undergraduate research program, which I will talk a little more in a minute. We think that those high impact practices I just mentioned is the key to get them involved in biotech workforce, in particular if they come from a non-STEM discipline. So summer 24, 25, 26, as you can see from my previous slide, they will be doing undergraduate research. Then they will be doing internship in the following years, and then they will be graduating and in the next year and become maybe possibly CGI consultant. So allow me to spend a little more time about the undergraduate research program that we are having. So as I mentioned, this is a summer program, 40 hours. They stay here in the dorm. They receive all kind of amenities, including library, access to our computing system, to the gym, of course, housing and food and everything. So it is a very typical RU program that National Science Foundation or other federal programs has. In between, they are mentored one-to-one by a faculty at the University of Louisiana at Lafayette. But on top of that, they receive many they attend many workshops to get both the technical skills and the soft skills, like as simple as participating in how to prepare professional posters, how to participate in 3-minute thesis, handshake type of thing from the career services. This becomes an extraordinary opportunities for them. What we have seen that mentorship opportunities, which I will show in a minute, has been the key of this success. Students, they live like as a component of learning community in the setup, both in the dorm and also in campus. They receive financial support as expected. They receive other opportunities, and at the end of the program, they are required and they were highly encouraged to present in a 3-minute thesis. We had a wonderful event at the end of last summer where we invited our university administrators throughout the state to be present and participate in their 3-minute presentations. Now, for the internship part, what our CGI colleagues will start this summer, again, this is a 40 hours, but that will be a 10 weeks program. This is, they have a very inbuilt program that they have at CGI. They provide them, of course, a red carpet onboarding. Weeks 2 through 9, they mix with the professional development. They have a different types of learning model they call CGI 70-20-10. Again, in the breakout room, you'll be able to know more about it because my CGI colleagues will be there. And again, they participate in some kind of leadership networking, client delivery, community service type of program. And the personal development plan, at the beginning of the internship opportunities, they will have that thing on the job training work plan. And professional skills, if you think about the branding, the financial literacy, the design thinking, presentations, networking, each of them are built in that internship program. So with all those things that we are doing, we just passed one summer, and we have done some kind of basic analysis that what is happening, what is the impact of that. So our program evaluator have done some survey, both pre-test and post-test, and one of the question was what is the impact of the mentor. And as you can see that you don't have to be a statistician here. The mentor helps me stay on track, or the mentor helps me engage in the program. Mentor checks with me regularly, or holds me accountable. The pre-test and post-test mean has a significant difference here now, which is very, very, very remarkable. And we have seen the impact of this undergraduate research program in terms of mentorship has been very successful. And I do not have enough time to show you all the data. But on the other side, we wanted to see the efficacy of this kind of career point of view. So if you look at that, again, just be mindful that out of the 17, 2 of the students are STEM students. They are engineering students. 15 are non-STEM students. And when we ask them the questions, I have the confidence in performing work relating to biotech. The pre-test mean was 2.93. It went to 3.06. So across the board, we have seen some changes in the post-test mean, which is a good sign. If you look at, I have the core competence in biotechnology knowledge. That mean went from 2.33 to 3.0. Is a good number, no doubt. But what I am very unsure of is their standard deviation is a little high. What does that mean is that means the improvement did not happen across the board, not across all 17 students. So this is something we are looking forward to address this year. But what the directions we are taking from here is we wanted to expand the cohort model, because it is almost certain that this type of learning community, both in terms of undergraduate research and internship opportunities, will give them the exposure to the biotech workforce that they have never thought about before coming to this program. So we wanted to involve our local partners, starting from the city to the state and to the federal level, that how we can adopt industry recognized credentials for students. We are working with different types of industry to have a short-term credentials program to long-term credentials programs as well. And the industry partnerships, because of this particular program, the industries have started coming together, both local industry and industries from other places. The nationally recognized companies, they have started coming to us and understand the model, and they're talking about how they can get involved in this kind of industry project. You may have seen that University of Colorado has a course-based undergraduate research program just for biotech workforce. In European Institute of Innovation and Technology, they have a PhD program that provides continuous interactions with the industry and the faculty. Johnson & Johnson, their J Labs, has a global initiative program for the PhD and postdoc level as well. We wanted to encourage them to get involved in undergraduate and in the master's level to confirm that. So to conclude, I think we have the takeaways is the multidisciplinary model that we talked about is the way to drive the biotech innovation. We think that high impact practices, again, those of you are familiar with, Professor George Kuo from University of Indiana initiated the high impact practices, and undergraduate research and internship are the two important of them. And learning communities is the other one. We think with this particular model, we are doing all three of them: undergraduate research, internship, and learning community. And we believe that that will make a significant difference. The call to action from here, we encourage our industry partners to come and get involved in this kind of programs so that we can move forward with this challenge. And finally, the way to address the non-STEM workforce is not just after they graduate, rather before they graduate. We should have them during their possibly during their sophomore year, and then take them through this journey of undergraduate research, learning community, and possibly internship, so that they can be involved, they can be included in the biotech workforce. That's all I have for you today, and I will be happy to answer any question you may have. Drew, back to you.
Awesome. Thank you so much, Dr. Das. As mentioned, we are now going to transition to our breakout sessions for Q&A and further discussions. What these breakout rooms, as mentioned, are for is just sort of deeper discussion into each of the presenters' work, their topics, and just space for community discussion, collaboration, etc. Breakout rooms are self-assigned and organized by speaker. I will go ahead and launch those breakout rooms now. So you should be seeing a pop-up on your screen allowing you to select a breakout room. If you don't see that pop-up, you can navigate to the bottom of your screen and select the breakout rooms button and click the room you'd like to enter. And if you're running an older version of Zoom and don't see the breakout room button, please post in the chat which speaker's room you'd like to enter, and we'll assign you to that room. We'll call everyone back to the larger group at 3:25 p.m. Eastern Time for a quick little conclusion, and I hope you all have a good chat. I know I pulled you back a little bit early. I got personally, selfishly, a little impatient because I would love to hear, and for the group people that were in the other breakout groups, if we could just do a little recap of what y'all were talking about. So Dr. Wang, if you want to start with what your breakout room was discussing, any highlights?
I think I got all these listeners. They are all interested in how to combine science and art into their, into their teaching or research, and they all, some of them were just starting to share what they are doing. I think they actually, some of them really incorporate art, real art, into their biology, the STEM class, rather than I'm developing interdisciplinary class. They actually use the art in their STEM class. So, and also they are just doing, we start to try to think about how can my talk maybe not relevant to how maybe they can think about the way. There's one thing they can do to actually incorporate the approaches, different kind of approach, interdisciplinary of way of thinking. They already did, probably many of them, maybe put them into the existing course, the existing way of doing, or their future, plan. So I thought that the interdisciplinary, it doesn't mean you have to be chemistry and art, maybe science and art, or maybe science and humanities, some other kind of classes, not strict to the art. So strict to the chemistry, physics. There are a lot of interesting physics phenomena when I talk about the origin of color. Color has a lot of to do to physics. So there are many, many things you can stimulates student interest in the way they ask me about what kind of really good question, how I select those students, how can I make the small class be so diverse. So I tell them exactly how I do it. I will just do basically ask them to show up 2 classes from beginning to the end. Then they shop me. In Brown, they have 2 weeks shopping period, 2.5. So I say, you have to shop me first 50 students, then down to 30. Then they have to write a little short essay, fill out the form. The second class bring back. Then you dwindle down 30. Then at the end, the self-selection rules. I get 12, 13, 16 students. So thank everybody who are in my breakout room. Yeah.
Thank you for sharing. I think bouncing
And
off that point.
one last question, in case some of you really need to collaborate in the future, you have more questions, always email me. My email is Li, my name, _ so I can help you. Maybe you can help us. We can help each other to really brainstorm some of interesting approaches in your teaching, maybe. Hopefully we're friends in the future.
Thank you. I was going to say, like, this type of topic already, as you're saying, different fields as humanities, sciences, arts, like it creates such a platform for collaboration, which it seems is going to be instilled in your students from just the setup of the course. So thank you. Dr. Dawes, would you like to comment, or your collaborator, Jacqueline, if there's anything you want to talk about from your breakout room?
Sure. I mean, my collaborator is here, but to start with, again, thank you so much, Drew and Dr. Wang. I enjoyed your presentation. Thank you so much. We discussed pretty interesting topics. Dr. Sheshar from George Mason asked pretty interesting questions that when I talked about the biotech workforce, he was talking about how the data literacy is playing a role here. And Jacqueline and I discussed that, yes, both the data literacy and the AI literacy will be has to be incorporated in the biotech workforce. And we talked about the way we are doing it and the way CGI, again, our corporate partner, industry partner in this project, is playing a very vital role. We talked about the mentorship that we are providing, faculty, student, and then industry partners to student type of mentorship, different models. And as I showed you in my data, that structured mentorship and kind of unstructured mentorship, both are playing very important role. And then we talked about some credentials coming out of industry that we encourage our students to consider. And again, in order to address that huge gap, we have to go for traditional approach, our 4 years, 2 years colleges, but also credentials that they have. And I believe Jacqueline was saying something when our breakout room got into this thing. So I don't know whether she wants to finish it or not. Jacqueline?
Hi, good afternoon. Thank you for that, Kumar. I was just sharing with the group at the end of in the NSF grant, at the end of the scholars summer undergraduate research experience, they really had a beautiful opportunity to do a poster presentation, and it was a community-wide event where, you know, certainly all of our CGA partners that are in that center of excellence, we have about 800 or so were invited. The community was invited, UL and the UL system leadership was invited, and the students were able to showcase all of the research that they had actively worked on, and both had that mentorship throughout that summer experience. And then they could take that and they could go and present at multiple other undergraduate research conferences with their same research project. That group of students will be coming to visit CGI this summer for their advanced internship. So we are excited to see them continue their research in our health and life sciences accounts. So that'll be very interesting. Thank you, Kumar, for that opportunity.
Of course. And I believe, I think I'm very proud of this transition that they will be doing from undergraduate research to internship, that legwork has been completed. I think we can proudly say that.
Yes. Thank you.
Thank you both so much for sharing. Now that we have a few extra minutes, I just want to see if there's any questions from the full group together. If anyone has a question, feel free to come off mute, put it in the chat, or to our two presenters. Now that we've seen each other's presentation, heard a little bit more, if there's any final points or remarks, either for each other's work that you just want to bring up, hold a little bit of space here.
So my name is Padu. I wanted to thank Kumar and the CGI, Jacqueline, for the whole, the collaboration and the partnership that they have built, which, is helping build not only skills for the students, but also setting up a trajectory for the career and all that stuff, which is great. Dr. Wang, thank you for that nice chemistry, integrating the A. I'm a big, not just STEAM, but stream with R for reading and writing with a W silent, so the literacy piece and all that. One thing I put on the chat when you were talking is I'm also very big with working with students on context. So, for example, if you think about the United Nations Sustainable Development Goals, many universities are right now focused on that. And so kids are motivated by a context that bothers them. So, for example, goal number 14 in United Nations Sustainable Development Goals is conservation and sustainability use of ocean, sea, and marine resources, right? So then the chemistry concept could be something like osmosis, and you can do an experiment. So you already have done, I saw something that you used water and things like that. So I think this is a great opportunity for them to, learn chemistry a different way, right? Like ocean acidification. So carbon dioxide and water and, carbonate ions making, I'm a mathematician, by the way. So making, bicarbonate and then, the consumption of that impedes the calcification. And so that kills the animals with shells. And so there is a huge
There's a
part
little bit
of
in the acid rain there.
acid
The
rain. So when you said
laboratory.
acid rain, that's exactly what I thought
Yeah,
of.
we had that intro video
Right.
shows
So
all
the
the
connection though from there to life underwater, which is
right.
we have like 2030 to finish these goals
Right.
or address them at least. So if the
Yeah.
next generation kids can address these through chemistry, through industry partnerships, through these things, I think it is much more impactful.
Yeah, we
I
could
see more and more
probably
kids want to change the world. So it's moving from research for consequence to research for impact. So
right. So actually, I'm very lucky. I'm working right now, as you said, 3 undergraduates volunteer for one of them independent research project. They're doing urban heating. It's very interesting. We change the traditional measurement. They just find some piece of wood, compare the concrete, they do some heating rates. Very interesting. A lot of them just play. Then we see whether now, I said, you have it's not just chemistry. Urban heating, why it gets so hot in a city? How you propose to get a better solution, you know what I mean? So they learn from heat capacity related to the urban heating. It's very interesting. There's so much. Thank you for that. For the under the water, we could actually link to the United Nations some goals for the water, water marine life. So maybe ask them to read a little more. But right now they're so busy, they just keep finishing up lab report down. It's really hard. Yeah. Thank you.
Oh, awesome. Thank you all so much. I'm gonna go ahead. I have some few closing remarks so we can get out of here before our 3:30 Eastern time end point. But let me pull up our last little bit. If I can find, yeah. This, as someone who consistently opens up too many tabs, makes it difficult to find what I want to share. So as said, before we go, I'd just like to thank our speakers and facilitators, the rest of the AAAS IU's team, and all of you who are able to join and participate in the workshop today. As mentioned, this is our first one of 2025. We have 3 planned for the spring and then 3 for the fall. So definitely a lot more content to cover. We have a survey link, which we're posting in the chat and sending via email. The survey version only took a few minutes, and we'd really appreciate your feedback as we continue to do our workshop series. As mentioned, a recording of the presentation and the speaker's slide deck will be posted on our website and emailed to you in the coming days. Once again, thank you all so much for joining us today, and we hope we'll see you at next month's workshop on Thursday, April 17th. That will cover empowering STEM students both in and beyond the classroom with Margaret Ellis and Dr. Krishna Pakala. And as always, we look forward to engaging with you and learning from you, our AAAS community. Take care and happy Tuesday. Thanks, y'all.
Thank
Thank you for having
everyone.
me.
Thank you, Drew. Thank you.
Thank you so much.
All right, Drew,
So-
we'll be in touch.